This is question 3 from Step Paper 2, 1991. We are given 3 equations on the basis of which we have to prove that x squared y squared z squared equals 1. So I could label these equation 1, equation 2 and equation 3. And the first step, obviously, is to get rid of fractions by multiplying both sides of each equation by yz, xz, or xy, as may be appropriate. So I'll now carry this out. And so I've now carried this out, producing equations 4, 5, and 6 on the right-hand side. And I have an instinct to adjust question 6 so that it follows the same pattern as the other ones, so that what we're going to get here is x, y, z plus y equals x squared y plus x. And so I now have the revised appearance of equations 4, 5, and 6. I want x squared y squared z squared, and my instinct is to get all the single letter expressions on one side and all of the expressions with 2 or 3 letters on the other. So this I now proceed to do. And so I have now produced equations 7, 8, and 9. And the next step in simplification is to factorize the left-hand side in each case. And this produces for me equations 10, 11, and 12. I want information about x squared y squared z squared. I've got yz, xz, and xy on there. And so obviously the next thing to do is to divide each of the elements on the left-hand side by x minus y, y minus z, z minus x, and that should lead to a further simplification. And so we can now see here that yz, we have an expression for yz, xz, and xy, which enables me to obtain an expression for yz, xz, xy, which is the same as x squared, y squared, z squared, and that will be as follows. And we obtain this expression here. But we can actually now see that we can do some cancelling. And if we look here, we've got x minus y, z minus x, z minus x, y minus z, y minus z, which shows that that expression is equal to 1 as required. In the last part, we are required to prove that x plus y, x plus 1 over y, is equal to plus or minus 1, which means that we're required to prove that x plus 1 over y is equal to plus or minus x, y, z. So if I multiply both sides by y, I am required to prove that xy plus 1 is equal to plus or minus xy, yz. And I can now use the expressions from this line here in order to fill in what's going on. So I am required to prove that xy, which is x minus y over z minus x, plus 1, which is z minus x over z minus x, is equal to xy, which is x minus y over z minus x, times yz, which is y minus z over x minus y. And so if we look at the left-hand side, I am required to prove that x minus y plus z minus x over z minus x, which is the same as z minus y over z minus x is equal to plus or minus, and if I look here I can cancel down x minus y, y minus z over z minus x, and that is true.